We often imagine the asteroid belt as a barren frontier, a scattering of rocks where miners chip away with pickaxes at metal and ice under the cold light of the sun. But like every frontier before it, that belt of drifting stone will not stay empty. Where people dig, they build. Where they build, they trade. And where trade flows, cities rise. Our descendants may one day live not on planets, but inside the walls they made themselves. Hollowed asteroids that grew from mighty outposts into self-sustaining city-states. Picture, if you would, a habitat a few kilometers across buried inside one, spinning for gravity, lined with pressure holes, life support gardens, and kilometers of tunnels converted into housing, factories, and foundries. Once it was a mine, now it's home to 1 million people, and it's mobile. Each of these asteroid cities begins with an economic spark. An ore body rich in nickel, cobalt, or water ice. Autonomous diggers and teleoperated drones carve out the resource. But soon, humans follow. Engineers, technicians, traders, and families. They bring workshops, then hospitals, schools, and entertainment. As infrastructure thickens, what began as a resource node becomes a permanent hub, then a self-governing settlement, and finally, a sovereign polity, an asteroid city-state. Unlike the old city-states of Greece or Renaissance Italy, these will not cluster on a single shore. They will orbit the sun in loose constellations, each following its own trade through the belt. The distances between them will be immense by terrestrial standards, but small in delta V. A few hundred meters per second of velocity change can connect them, making travel and exchange practical for ships powered by electric thrusters, compressed gas, ion drives, or solar sails. In this ecosystem, no single asteroid enjoys overwhelming power. The belt contains millions of viable rocks, many thousands of which could host entire major nations, and automation will keep resource competition fierce. Instead, initial prosperity comes from providing precious metals or raw materials back to Earth orbital industries. It offers settlers the space equivalent of virgin land. Settle here and work hard, and a handful of generations all the streets and landmarks are named after you. Further prosperity will come from specialization, habitats that craft unique alloys, rare isotopes, art, biotech, or even luxury ice and wine brewed from cometary volatiles. Because asteroids are close enough and low enough delta V, trade between them and almost anything becomes viable, and each asteroid could potentially specialize in a handful of trade items. Everybody grows hydroponic wheat or corn, but you decide to give 10% of your growth space up to making mustard and getting good enough at it that your price and quality creates a demand. Someone else does cayenne pepper, someone makes silicon chips, someone else makes cooling fans for computers. Cottage industries in space. And they can trade not just goods, but expertise, designs, and ideas, linked by a network of freighters and data relays. Every habitat has a sickbay or a small hospital. Yours is the one that specializes in eye surgery. Over time, these communities will develop their own laws, currencies, and cultures, perhaps proud of their orbital independence, perhaps wary of Earth's influence. Some will cluster in leagues and federations for mutual defense and trade standards. Others remain fiercely independent, roaming the belt like mobile city-states, slowly shifting orbits as they follow contracts or new resource veins. Today we explore how these asteroid city-states might form, from the first mining camp hollowed into rock to bustling metropolises of millions, and how life, law, and commerce evolve when the only borders are trajectories and delta V budgets. From mines to habitats. It starts small, a handful of drones and prospectors, mapping mineral veins in a tumbling rock just a few kilometers wide. The first steps are always automated. Robotic excavators, solar smelters, and microwave drills carving out metal for construction or shipping home. These early operations are lean, remote-controlled from light minutes away, and designed for simplicity and redundancy. Then come the maintenance crews, the first people to live there, at least for a few months. You could have a ship with a small rotating section that drifted between a dozen mining sites, providing annual maintenance as opposed to crews at each. Or perhaps both, roving ships and outpost crews they visited. Any which way, they need air, water, radiation shielding, and a pressurized shelter that can double as both habitat and workshop. Initially that means inflatable domes and small modules, but before long it's easier to start converting the mine itself. The shafts are sealed and lined with a regolith or metal plating. then spun for gravity using a mass driver or tether system, maybe the same ones they are used to ship ore out, to central collection depots or back to Earth itself. At first, these are just underground camps, a dozen workers sleeping in bunk beds beside machines that keep them alive, probably at the bottom of some crater and connected to the outside world by a trunk line running up to the rim walls or polar solar panels and antennae. But humans have a way of turning any outpost into a home. Greenhouses sprout to balance oxygen and carbon dioxide, and to provide some fresh fruits and vegetables. A mess hall becomes a cafe, then a pub, serving whatever alcohol they can brew out of whatever plant material they can't or don't eat, feed some fish or maybe even chickens, or convert to plastic feedstock for a 3D printer. The supply depot grows into a central hub with hangars for visiting ships. As more mines go operational and begin producing steady streams of refined materials, a new kind of construction begins, turning the asteroid into a habitat. Metal-rich asteroids offer a ready-made structure, their own hull, bulkheads, and shielding. Ice-bearing ones can supply water and air. The more resources they can source locally, the less dependence on supply shipments from Earth or Mars. Over time, one or two major bodies in each cluster become centers of gravity, figuratively and literally. They host refineries, communication arrays, power systems, and hospitals. Their tunnels expand, pressure domes multiply, and families arrive to support the growing workforce. Before schools, governments, and local currencies follow. Growth of population and infrastructure. Once an asteroid has more than a few hundred residents, it begins to function more like a small town than a camp. Local administration emerges, may be run by the mining company at first, and then later by a council of workers or residents, or their newly emerged tyrant. There's a lot of history for all of the above and more. Power plants grow larger and more complex. Instead of portable nuclear reactors, solar panels, or mirrors concentrating light to heat solar thermal plants, emerging cities might be able to build compact fusion cores or buy solar beam power from orbital mirrors closer to the sun. Recycling systems expand until the habitat becomes nearly closed-looped. Scaling up a habitat is both an engineering challenge and a social one. For every new 100 residents, you need more oxygen, food, living space, radiation shielding, and social structure. At a few thousand, you have the critical mass to justify amenities, cafes, medical centers, sports fields. At 10,000, a full civic economy begins to appear. This is about when you might be wanting to build a full-scale Stanford Torus for everyone to live on, or as the new central area to connect a dozen or more von Braun wheels or Kalpana 1-sized settlements. I don't think we'd often build any habitat bigger than what a tenth or maybe a quarter of the population of the settlement would fill, or often decommission smaller habitats while they still worked. In fact, I would not be surprised if a lot of larger asteroids became rabbit warrens of tunnels filled with thousands of minor rotating habitats in various states of disrepair, though nothing stops you from keeping them in tip-top shape indefinitely if you have the manpower, money, or automation to keep them up. Like neighborhoods of city, they likely have regions that undergo cyclic decay or regrowth. It is worth noting that when the United States first became a sovereign nation, our two biggest cities, New York and Philadelphia, both only had about 30,000 people. That's also bigger than the largest city in the county I live in. Given that pioneer and frontier life tends to both self-select and breed for independence, I could see them already viewing themselves as their own sovereign entity or near enough. And the classic city-states like Florence or Genoa only had 3 or 4 times that population in their time. At the same time, we should be mindful these folks probably expect way more services and need bigger supply chains than the American pioneers needed, for instance. Or maybe not. 3D printing and other automation might seriously decrease how big a population you need to create a high-tech and mostly self-sufficient economy. And AI can help with a lot of specialization, and you can farm out a lot of specialty work to consulting groups back on Earth or elsewhere in the belt. Your colony probably does not need a professor of Greek antiquities or a specialist in ear medicine on hand on your asteroid. I would guess by 100,000 people on an asteroid, you have city districts and internal transport systems, rail lines or rotating ground levels for artificial gravity. You could easily have personal spaceships that need not be very expensive or high-tech to operate the low delta V of inter-asteroid travel, but it's also not a great setup for cars or personal rovers, that near-zero gravity environment. A lot would depend on how easy it is to build infrastructure like a tunnel or tether line compared to building a small personal craft. There's a common assumption about such self-sustaining colonies that with 3D printers and nanofabrication, they can make everything they need locally. It isn't possible to speak with certainty about technology a century or more from now, and asteroid states are probably a 23rd century development or later. but I feel the weight of current evidence is that manufacturing even in the more distant future still favors specialization. While asteroid habitats will certainly use additive manufacturing, printing spare parts, housing modules, and custom tools, the deeper truth is that advanced goods depend on complex supply chains. Or perhaps more accurately, cheap advanced goods depend on complex supply chains. A single 3D printer cannot produce its own superconducting magnets or precision optical arrays, or cannot easily refine dozens of trace elements needed for high-end electronics. Even if it could, economies of scale make it inefficient. It is far better for one habitat to become expert in producing microchips, while another focuses on pressure suits or medical nanotech. The result isn't self-sufficiency, but interdependence, a distributed web of cottage industries and high-tech workshops scattered across the belt. Each city-state becomes a specialist node in a larger network. One might manufacture precision bearings for ion thrusters, while another grows genetically engineered algae optimized for oxygen production and protein synthesis. Yet another might specialize in decorative alloys or tailored gravitic plating for spacecraft interiors. Together they form a self-reinforcing economy, local, agile, and robust, where goods and knowledge flow almost as freely as data. Because of the belt's unique dynamics, trade remains cheap in energy even if it takes weeks or months in time. Ships can follow low delta-V spirals between asteroids, trading bulk goods like water and metals or fine items like electronics and art, carrying visitors or migrants or journeyman tradespeople. Your circuit judge arrives on the freighter from New Guadalupe, along with a couple crates of fresh pineapples and a dozen other long-sought cargoes like bolts of cloth from the place that got silk production going. And since many of these routes are cyclic and predictable, you could have a near-constant slow freight network looping through the inner system, carrying goods, messages, and people. This combination of 3D printed adaptability and specialized trade gives Belt civilization its texture, not a monocultural self-sufficient outpost like we see in The Expanse, but a living web of small communities, each proud of its niche. You print your own utensils, furniture, and repairs, but you import your computer cores, medicine, and luxury fabrics. You know how to make almost anything if you must, but it would take a while to get production running at all, let alone at modest efficiency, and it's cheaper to buy from elsewhere, and you focus your effort on doing what you do best, building up some other niche. It's the same principle that often made Venice or Athens great, mastering what you do best and trading for the rest. You can be self-sufficient if someone enacts an embargo, but it would be hard times. You'd be able to survive, but not to prosper, at least not as much as you would by trade. Since we're human, this is likely to often involve some less than admirable or fair practices, and while I am phrasing this all in a loosely mercantile or capitalist framework, I would rather expect we'd see a pretty big variety of economic and political models at play in the asteroid belt, including a lot of hybrid and overlaps. You'd also have a dozen different asteroid colonies, each with their own economic system, from laissez-faire capitalism to communism, who have confederated trade akin to the modern system we see at the international level. I know a lot of folks like to assume their preferred system will win out in the end, and you might be right, whichever system that is. But I tend to assume a future spacefaring humanity probably is about as unified in purpose and vision as nowadays, and about as permanent in each of those states as now too. Things change with time, and with growth too. I also think, loosely speaking, when a habitat grows past the 100,000 mark, something changes in character. It starts to think of itself as a place and people, not a project. Residents are born there, live there, and may never visit Earth. Architecture evolves beyond necessity. Parks, theaters, and temples emerge, shaped by artificial gravity and constrained by cylindrical walls. You build a museum. You start having an actual history that needs written down and shared because most of the people here no longer have even met, let alone know, the original founding 100. The people identify not as Earth expatriates, but as citizens of Ceres, Pallas, or Eros, or perhaps the Habitat Union of 88 Astria. By the time a city reaches 1 million inhabitants, it may have a university or two, research labs, and artistic movements. It may host consulates from nearby asteroids, trade guilds, or religious orders. Its mayor debates orbital zoning laws with other city-states, and all this began from a few autonomous drones scraping nickel from a rock. Economics of the Belt. The asteroid belt's greatest strength lies in its sheer size and diversity of composition and position. Every rock out there is a unique combination of metals, silicates, carbon compounds, and frozen volatiles, and that patchwork of composition ensures that no single habitat can dominate the economy, especially as each rock is also only near so many other rocks and at any given time. Asteroids in the belt are not on some fixed map. Each has an elliptical orbit with a trajectory and period of its own. In any given temporary region, one asteroid might yield nickel-iron in industrial quantities, another cobalt and platinum, another still a motherload of hydrated silicates and frozen carbon dioxide. This resource scatter all but guarantees specialization, because the cost of moving bulk material, even with cheap energy, is rarely worth competing in someone else's niche, though you may have no choice as two iron-rich asteroid mining city-states might cross near each other and have to split the customer base, or spend more time and energy moving their product further away. And the belt is unlikely to be a super-rich area where energy is concerned, especially the dark outer regions where ices are most readily available. Over time, the belt's economy probably becomes a tapestry of complementary industries and, importantly, one that trades mostly with itself. Doubtless it will have robust trade elsewhere in the solar system, but the bulk of it will increasingly internalize as more and better specialized and hard-to-manufacture items can be done internally. While the example will likely be archaic by then, at some point you develop your own TV and radio stations, your own sports leagues, your own video game companies, your own movie studios. They are never your exclusive sources unless you are a heavy isolationist, but they become your main sources. And as we are seeing, there's a lot to the economy besides metals and rocks in the belt. That is fundamentally the basis of that economy, much as timber or croplands or pastures often have been for growing communities here on Earth, and sometimes metals and mining too. Metal-rich asteroids export raw stock and precision alloys. Icy bodies supply volatiles for air, water, and chemical feedstocks. Carbonaceous chondrites feed organic chemistry and polymers. Once habitats begin refining locally, they naturally branch into value-added production: cable sheathing, radiation shielding, mirror arrays, circuit substrates. It's the same progression every frontier experiences: the jump from raw extraction to refining, from refining to craftsmanship, and from craftsmanship to art. A critical factor keeping all this running smoothly is energy. Solar power fades with distance, but that's counterbalanced by the belt's near vacuum and abundance of metals. Thin film mirrors kilometers wide can beam energy to multiple habitats, while portable fusion reactors and isotope heat sources keep the mines hot and smelters running. I think when I talk about giant mirrors, people tend to assume vast cost and effort building the things, but without wind and gravity, these mirrors need no more weight or sophistication than shiny tin foil. At Earth distances, a square foot might reflect 100 watts. A square meter of such foil might reflect a kilowatt of power, enough to run a modest household, albeit a meager one. How much does a roll of tin foil or aluminum foil cost? How many square feet or meters does a roll have? You might need 10 times as much out there, and the production might be harder than on Earth, especially initially. But if you manufacture a lot of aluminum, you can manufacture a lot of foil and mirrors. Power beaming and microwave starts topping out usefully at the multi-AU range. We'll be exploring that more in our upcoming Deep Space Habitats and Interstellar Relays episodes. But as an example, you start needing an emitter multiple kilometers wide, targeting receivers even bigger, to send microwave power efficiently over several AU, such as to the belt. That's perfectly viable if the power levels involved are in the high gigawatt to terawatt range. As a result, many city-states may end up trading power itself, and while power levels will fluctuate for a given asteroid over its orbital period of 3 to 6 years, as those are elliptical and thus closer or further from the Sun, they do not fluctuate over the course of the day. You can literally hang sails off the sides of asteroids. They're not that big and they have no meaningful gravity. Energy beaming is easier out there too, so peak production asteroids or those on closer orbits might beam energy to more distant neighbors, or receive it from them. Energy credits may become common as currency basis, or they may use an Earth-based currency or some local fiat currency or some metal-based one. It is probably worth noting that for most objects in the belt, Earth is closer to them than the majority of the belt. It is a huge and diffuse volume, so unless there is a solar system-wide main currency, akin to the modern US dollar, which is hardly the only currency either, you could have trade in a dozen different currencies, fiat or commodity, traditional or crypto, or something else entirely. And through it all, I think by default the economic balance tilts towards cooperation rather than conquest. This doesn't mean hostilities wouldn't occur or even turn to full warfare, but capturing another asteroid isn't easy or profitable when it's cheaper to sign a trade compact. Your basic asteroid is best thought of as a mountain fortress. It can be worn down through embargo or siege, but direct and fast assault is likely to be a meat grinder. The belt's political economy likely evolves into a mishmash of treaties, free trade pacts, mutual defense leagues, and arbitration courts, each regulating Delta V tariffs and mineral rights the way old maritime laws once governed shipping lanes. The freighters that carry goods between habitats might fly under charter flags, recognized across the system, enforcing safety and dispute protocols through insurance rather than empire. One of the more curious aspects of this economy is its speed, or rather its lack thereof. Information moves at light speed, goods do not. Low delta V makes trade possible, but the distances are still big. The belt is not evenly distributed by any means, but if for simplicity we treat it as a homogeneous torus or donut with about 1 million minor planets worth settling, then any given asteroid's dozen or so nearest neighbors are typically a couple million miles away, several times the distance to the moon from Earth. Now, you might only need a ship with 5 kilometers per second of delta V to travel between those, far less than to get from here to the moon, and requiring maybe 1 or 2% of the fuel per ton of cargo. But at such a speed, needing to slow down too, you might need a few million seconds to get there, which is several days. Now, there's many ways to make that trip go faster, but they take more energy and propellant and thus presumably cost, or they require a launch infrastructure like tethers or a mass driver. At some point, you would rather go a bit slower and replace some of your fuel with more cargo. Technology and time will help determine what that optimal point is, and it will also depend on the cargo. If you're carrying rock or wheat, it's not as urgent as bananas. But your ship and crew do have a daily maintenance cost too. This slow but steady commerce brings to mind the age of sail, and even well into the industrial age, where trade was often about patience and reliability. Contracts that stretch years, fortunes built on timing orbital alignments, and trading houses that specialize in predicting celestial mechanics as much as market demand. Who will be your trade partners next decade, and what do they specialize in and what do they want? Trade and communication networks. The workhorses of the belt will be ion drive freighters, nuclear electric tugs, and magnetic rail launchers that hurl cargo pods along predictable orbits. Because so many asteroids share similar orbits, albeit somewhat temporary ones, the belt naturally develops routes comparable to the ocean currents or jet streams. Some are chains of small settlements forming refueling and repair stops, others are high-traffic corridors linking the largest city-states. The busiest of these may even gain names: the Cirrus Loop, the Palace Run, the Eros Corridor, each potentially with its own customs, patrol services, and trade conventions, and again, mutating over time. And multi-asteroid nations may arise based on these. Over centuries, these networks start to resemble a circulatory system, pulsing with people, goods, and information. Communication is far faster, but no less crucial. Data lasers and relay satellites knit the belt together into a single infosphere, but not a belt-only one. Unlike spaceship routes, communication is entirely about distance, and to any given asteroid, Earth and Mars were typically closer than much of the rest of the belt. No one's more than an hour away by a comm laser, but nobody's close enough for real-time communication. That distinction between the physical and informational economies will likely shape how asteroid habitats form relationships with their neighbors and with Earth, especially after discussed confederating into something larger. This is why I think asteroid city-states are more probable than centralized empires. Asteroids do not stay put. Even within the same family, their orbits are in constant motion, so you never have the same neighbors for long. Imagine if pre-EU Europe were made of countless duchies and principalities that drifted randomly across the continent every decade. Big kingdoms would have a hard time holding together. They usually did even without the landscape changing. The belt, by its very nature, resists centralization. No capital rules the void, except maybe Earth, and no single currency ever fully dominates. Instead, a patchwork of standards emerges. Mutually recognized digital signatures, Delta V accounting ledgers, and a web of common law trees enforced not by armies but by reputation. Asteroid city-states are all about treating space as something you can engineer and manage: energy, mass, momentum, even entire moving worlds. But one of the stranger resources any advanced civilization has to deal with is time itself. That's the focus of this month's Nebula exclusive, Chrono-Engineering, Manipulating Time as Technology. It looks at what known physics already allows, like relativistic time dilation we account for in systems like GPS, and then pushes outward toward more speculative ideas, from causality engineering to what happens when time becomes something you actually have to allocate. Every month for years, I've released an exclusive episode on Nebula, along with bonus content and extended editions, dozens of episodes you won't find anywhere else, and it's also where every SFIA episode premieres early and without ads and sponsor reads. Right now, Nebula is offering a 3-day free trial, and with my link or the QR code on screen, you get 50% off a yearly plan, just $30 for the whole year, about $250 a month. Head to go.nebula.tv/IsaacArthur and start watching today. Politics, law, and the shape of Belt civilization. Politics in the belt is an exercise in practicality. You cannot send in the cavalry when your nearest neighbor is 2 months away by ion drive, and you cannot conquer what you cannot hold. The cost of direct warfare, fuel, time, and opportunity, makes it far cheaper to negotiate, embargo, or simply outcompete. The result is probably a political ecosystem closer to the Hanseatic League than the Roman Empire, hundreds, maybe thousands of semi-sovereign city-states bound together by mutual treaties and trade compacts. You could even have dynastic clashes and inter-asteroid political marriages. Most inter-asteroid disputes get settled by arbitration courts or economic sanctions, probably. Violence when it happens is local, security forces quelling mutinies or pirate raids, not full-scale wars. Piracy and privateering might be a big thing, but space does not permit much in the way of stealth. I could see an era when the belt was developed enough to have trade worth pirating, both internally and back home to Earth, and where sensor systems were not yet powerful enough and widespread enough to track ships constantly. There is no horizon in space and nothing to hide behind, and do not think you can dash behind an asteroid and hide or change directions unnoticed. It would be like using a jetpack to dash between a dozen lone trees spread across all of Kansas. You're not hiding from anyone that way. But nobody builds and maintains an expensive detection grid till there's enough need to justify the cost, so you could have an age of piracy in the belt, much as we had in the Caribbean. This kind of situation rewards cooperation between neighbors, but only if they want mutual benefit. Historically, piracy was often state-sponsored, and internally you could have a lot more strife. A belt governor who mishandles air recycling or power distribution won't face a no-confidence vote, they'll face suffocation. Initially, it's probably government stripped the essentials. Maintain the habitat, keep the trade running, don't make enemies who can cut off your energy feed. Your miners are not folks you can threaten with a whip either. They are likely very technical folks whose job it is to repair robots. I'd like to think it would trend to democratic assemblies, but that's hard to say. Even assuming it wasn't founded by a totalitarian state back home, or a corporation out of the worst cyberpunk traditions, a city-state might fall under the control of its power consortium, a union of shipyards, or even a charismatic AI. But the absence of distance-based dominance makes tyranny harder to export. Each habitat has the power to unplug itself, literally and politically, from a system it no longer trusts. Independence isn't a rebellion, it's just closing an airlock. Indeed, they can flat out leave. With enough energy you can start using your excess raw materials, your less valuable spill from mining, as propellant to move your whole asteroid. A high-efficiency ion drive might let you sacrifice as little as 1 or 2% of your mass to achieve a delta V of kilometers per second, pushing you into a very different region of the belt. And if you want to do more or import propellant, you could push yourself out of the belt entirely, even to the deep space beyond the Kuiper belt if you want. Assuming you've got fusion reactors, you could opt to become entirely interstellar, though we will save such discussion for our Deep Space Habitats episode in a month or so. The Mature Belt Civilization. By the time the belt reaches maturity, the distinction between asteroid and spacecraft will blur entirely. Many smaller city-states will be mobile, massive habitats with drives powerful enough to nudge them in new orbits, maybe even looping out to connect with megatankers carrying hydrogen from Jupiter. An asteroid might spend decades parked in one trade cluster before migrating elsewhere, and again to some degree they all do move with time. The belt becomes a slow ballet of cities, drifting through shared lanes, docking and departing like celestial caravans. Moving day might take years or decades, but entire populations could resettle closer to allies, trade routes, or energy sources. For bigger asteroids, they may become more permanent hubs. Because with little thrust and effort, small ones can be bound to them permanently. Indeed, they may be connected by physical tethers of space elevator strengths. Inside those bigger asteroids, 100 miles or so in size, and more so in the titans like Ceres or Vesta, you might have thousands of full-sized or neo-cylinders, each home to 1 million people, buried on or near such bodies. Those asteroids could then each be home to billions without feeling even a little crowded by modern standards. And all of it begins with resource extraction. The first mining rigs carve not just tunnels but futures. The first habitats turn not just profits but the wheel of civilization. From a handful of pioneers cutting ore in the dark comes a network of worlds brighter and freer than anything humanity has ever built before. The Light of 1,000,000 Worlds. In every age, civilization has grown where trade and curiosity intersect. The Bronze Age gave us city-states on river deltas. The Renaissance gave us republics on the sea. The Space Age will give us city-states of the belt, each born from stone and sunlight, each alive through human will. Sci-fi loves to show us sparsely habited planets and talk of galactic empires of a million worlds, but that future is far more likely to be compacted into our asteroid belt alone. They are big enough to support trillions, if not quadrillions, of humans in comfort. That's a more distant time, and in the early days things will be far smaller. They will not be the richest worlds nor the most comfortable. Their air will be recycled, their gravity simulated, their light reflected, but they will be ours, forged from ingenuity, independence, and the endless drive to build something new. And in that belt, a million sovereign worlds will spin, each a spark in the darkness, each a monument to the idea that civilization is not bound to one planet or one sky. It follows us wherever we go, carried by the same hands that once built ships of wood and cities of marble. Now those same hands will build in steel and starlight, shaping a future where the hum of machinery replaces the crashes of waves, and where every asteroid may yet become a world unto itself.